NENOMATICA, where mathematics meets YouTube excellence. Here are 3 essential facts about polynomial zeros that we will use. 1. An nth degree polynomial has exactly n zeros, counting multiplicity. 2. If it is a zero of the polynomial, then x minus a is a factor. 3. If x minus a is a factor, then it is a zero of the polynomial. In this lesson, we will find all zeros of the polynomial p of x equals x cubed minus x squared minus 4x plus 4, given that x equals 2 is already known to be a zero. We'll follow a clean, visual, step-by-step approach using the factor theorem, synthetic division, and simple factoring. Example, given x equals 2 is a zero of p of x, find all zeros. We'll mark our steps clearly on screen. Step 1. Factor theorem. Because x equals 2 is a zero, the factor x minus 2 must divide p of x. That is, p of x equals x minus 2 times q of x for some quadratic q of x. Next, we will find q of x using synthetic division. Reading the bottom row, the quotient coefficients are 1, 1, and negative 2. Therefore, the quotient polynomial is x squared plus x minus 2. So p of x equals x minus 2 times x squared plus x minus 2. Next, we factor the quadratic. Step 3. Factor the quadratic x squared plus x minus 2. We look for 2 numbers that multiply to negative 2 and add to plus 1. Those numbers are plus 2 and minus 1. So x squared plus x minus 2 factors as x plus 2 times x minus 1. Therefore, p of x equals x minus 2 times x plus 2 times x minus 1. Now set each factor to 0 to obtain the zeros x equals 2, x equals negative 2, and x equals 1. Example, we are given the polynomial f of x equals x cubed plus k, x squared minus x minus 2. We are told that x equals negative 2 is a zero. Our goals are: first, find the value of k that makes this statement true. Second, once k is known, find all zeros of the polynomial. Step 1. Use the zero factor idea. If x equals negative 2 is a zero, that means f of negative 2 equals 0. Let us visualize substitution into the function as a function box. We plug x equals negative 2 into f of x. Carefully simplify each term. Set the result equal to 0 and solve for k. Step 2. Now that k equals 2, write the full polynomial and factor it. With k equals 2, f of x equals x cubed plus 2x squared minus x minus 2. Factor by grouping. Group the first 2 terms and the last 2 terms. Factor out x squared from the first group and negative 1 from the second. Notice the common factor of x plus 2, so factor it out. Then recognize a difference of squares x squared minus 1 equals x minus 1 times x plus 1. Set each factor to 0 to find all zeros. In this guided example, we will solve a quadratic puzzle using Vieta's formulas and a parity argument about primes. We are given a function f of x equals x squared minus bx plus c. The zeros, alpha and beta, are prime numbers. The coefficient b is odd. We also know that f of negative 1 equals 42. Our goal is to compute f of 4. Step 1. Let alpha and beta be the roots of the quadratic. By Vieta's formulas, the sum alpha plus beta equals b. This connects the roots directly to the coefficient of x. Step 2. Since b is odd, the sum alpha plus beta is odd. The only way 2 primes add to an odd number is if one of them is even and the other is odd. The only even prime is 2, so we must have one root equal to 2. We will set alpha equal to 2. Step 3. With alpha equal to 2, we can write the quadratic as f of x equals x minus 2 times x minus beta. Now plug in x equals negative 1. We have f of negative 1 equals negative 1 minus 2 times negative 1 minus beta equals 42. That is negative 3 times negative 1 minus beta equals 42. Divide both sides by negative 3 to get negative 1 minus beta equals negative 14. Add 1 to both sides to get negative beta equals negative 13, and therefore beta equals 13. Step 4. Now that we have both roots, alpha equals 2 and beta equals 13, the function is f of x equals x minus 2 times x minus 13. To find f of 4, compute 4 minus 2 times 4 minus 13, which equals 2 times -9, which is -18. Quick recap. 1. Vieta gives alpha plus beta equals b. 2. Since b is odd and the roots are prime, one root must be 2. 3. Using f of -1 equals 42, we solve for beta equals 13. 4. Plug in x equals 4 to get -18. Great work! You have now seen how algebraic structure and number theory facts about primes combine beautifully to solve this problem quickly and clearly. In this lesson, we will solve a geometric algebra problem about a parabola and a triangle formed by its intercepts. The quadratic is y equals 2x squared minus open parenthesis m plus 2 close parenthesis times x plus m. The x-intercepts, together with the y-intercept, form a triangle whose area is 3/4. Our goals are to find the possible values of m, and then compute the x-coordinate of the vertex for the related parabola y equals x squared minus mx plus 1. Step 1. Find the zeros using the sum of coefficients trick. If the sum of plus b plus c equals 0 for the monic equation, ax squared plus bx plus c, then x equals 1 is a root, and the other root equals c over a. Here, compute 2 minus open parenthesis m plus 2 close parenthesis plus m. That simplifies to 2 minus m minus 2 plus m, which is 0. So the roots are x equals 1 and x equals m over 2. Step 2. The y-intercept occurs at x equals 0. Substituting x equals 0 gives y equals m. The triangle has its base along the x-axis between x equals 1 and x equals m over 2. Its height is the absolute value of m along the y-axis. Step 3. Use the triangle area formula. 1/2 times base times height equals 3/4. That gives 1/2 times the absolute value of 1 minus m over 2 times the absolute value of m equals 3/4. Equivalently, the absolute value of m times quantity 2 minus m, all divided by 4, equals 3/4. Multiply both sides by 4 to obtain absolute value of m times quantity 2 minus m equals 3. Solving, we get m equals -1 or m equals 3. To build intuition, let us sketch the triangle for m equals -1. The x-intercepts are at x equals 1 and x equals -1/2. The y-intercept is y equals -1. The base is the distance along the x-axis between those intercepts, and the height goes vertically to the y-intercept. Now sketch the triangle for m equals 3. The x-intercepts are at x equals 1 and x equals 3 over 2. The y-intercept is y equals 3. Again, the base lies on the x-axis between the intercepts, and the height reaches the y-intercept on the vertical axis. Step 4. For the quadratic y equals x squared minus mx plus 1, the x-coordinate of the vertex is -b over 2a, which simplifies to m over 2. Therefore, when m equals -1, x sub s equals -1/2. And when m equals 3, x sub s equals 3/2. Final answer. The parameter m can be -1 or 3. The vertex x-coordinate for y equals x squared minus mx plus 1 is m over 2, that is -1/2 or 3/2 accordingly. In this lesson, we will solve a projectile height problem modeled by a parabola, and we will do it step by step with both algebra and a helpful graph. Here is the problem. Part A. How many meters does the ball travel horizontally before it hits the ground? Part B. What is the maximum height the ball reaches? So, h of x equals 0 implies -0.03 x times x minus 36 equals 0. Expand to -0.03 x squared plus 1.08 x equals 0. Factor to get x times -0.03 x plus 1.08 equals 0. Therefore, x equals 0 or -0.03 x plus 1.08 equals 0, which gives x equals 1.08 over 0.03 equals 36 meters. So the ball travels 36 meters horizontally before it hits the ground. Part B. The maximum height occurs at the vertex of the parabola. from the expanded form negative 0.03x squared plus 1.08x. The x-coordinate of the vertex is negative b over 2a, which is negative 1.08 over 2 times negative 0.03, equal to 1.08 over 0.06, which is 18. Now, evaluate the height at x equals 18. H of 18 equals negative 0.0. 3 times 18 minus 36. That becomes negative 0.0. 3 times 18 times negative 18, which equals 9.72 meters. So, the maximum height is 9.72 meters at x equals 18 meters. Let us mark the vertex on the graph and draw the line of symmetry through x equals 18 for a clear visual of where the maximum occurs. To summarize, the ball travels 36 meters horizontally before landing, and it reaches a maximum height of 9.72 meters at 18 meters horizontally from the start. In this lesson, we will solve a lens profile problem modeled by the parabola y equals x squared minus 8x minus 20. We will find the x-intercepts a and b, compute the length of segment AB when x is in centimeters, and determine the maximum thickness of the lens, which corresponds to the lowest point of the parabola measured in millimeters. Let's draw the graph to build intuition. Here is an axis with appropriate scales x from -4 to 12 and y from -40 to 10. Now, we plot the parabola y equals x squared minus 8x minus 20. Notice it opens upward, and its lowest point will be below the x-axis. Part A. To find the x-intercepts, set y equal to 0. We solve x squared minus 8x minus 20 equals 0. This factors as left parenthesis x minus 10, right parenthesis times, left parenthesis x plus 2, right parenthesis equals 0. Therefore, x equals negative 2 or x equals 10. On the graph, these intercepts are the points A at negative 2, 0 and B at 10, 0. Part B. If x is measured in centimeters, the length of AB is the absolute difference between the x-coordinates. So, absolute value of 10 minus negative 2 equals 12. Let's show that on the x-axis as a measurement of 12 centimeters. Part C. For a symmetric lens, the maximum thickness occurs at the vertex of the parabola. The x-coordinate of the vertex is given by negative b over 2a, which is 4. Substituting x equals 4 into y gives y equals 16 minus 32 minus 20, which is negative 36. The maximum thickness equals the absolute value of that minimum y value, so 36 millimeters. Let's mark the vertex on the graph and draw the vertical thickness up to the x-axis at x equals 4. Summary. The intercepts are a at negative 2, 0 and b at 10, 0. The length AB is 12 centimeters. The maximum thickness at the vertex is 36 millimeters. Great work! Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.